The twist drill is the most widely used tool in industry. Every day, many millions of holes are drilled in a variety of products from ships and aircraft to watches and instruments. To produce holes in all the different types of metals, twist drills are used singly or in multiple setups and drill vertically, horizontally, or from any angle. The twist drill is a precision-made tool and deserves to be treated with care and forethought. As much care and forethought as the manufacturer has put into the making of it. Every part of a drill is designed to do a particular job. Its geometry has been calculated with minute accuracy and manufactured to very close tolerances. Obviously, the cutting is done by the drill point, and the angles of clearance behind the cutting lips are critical. The chisel angle is important, as the action of the chisel will determine the accuracy of the hole. The flutes carry the waste material clear of the cutting edge and also allow the passage of coolant to the point. The shank makes firm contact with the socket of the machine, and this contact provides the only source of drive, commonly known as friction drive. The tang on the shank is not intended to transmit the drive. It's only there for ejection purposes. At this factory, there is rigorous quality control and inspection at every stage of manufacture. To make sure that the steel used conforms to the company's rigid metallurgical specifications, each bar is critically examined. As soon as they are received, the bars are tested ultrasonically for flaws. This is how a flaw shows up on the oscilloscope. Any bar showing a defect is immediately rejected. From the acceptable bars, samples are cut off and submitted to the laboratory for detailed metallurgical examination. If the steel conforms to specification, it is then released for production. There are something like 60 different operations in the making of a drill. The first operation is to cut off the steel to the required length. Taper shank drills have a high-speed steel body which is flash butt welded to carbon steel for the shank. Copy lathes are used to turn the shank and body simultaneously. Milling machines are then used to produce the tang and the flutes. The flutes of the drill are specially shaped so that when the correct point angle is produced, the cutting lip forms a straight line. The flutes of smaller drills are produced by grinding. Another method is roll forging, where the high-speed steel blanks are induction heated and passed between revolving carbide dies to form the flutes and body clearance. Obviously, the drill must be harder than the material it is to cut, yet it must not be so brittle as to chip or break. Heat treatment is therefore a most important factor, and very rigid standards are kept. After heat treatment, the drill is finished ground to close tolerances by cylindrical grinding or centerless grinding in the case of jobber drills. So we have come to the point, the most important feature of a twist drill. The accuracy of the holes and the efficiency of the drill depend on correct point grinding. At this factory, hundreds of thousands of drills are made every week, and they all leave with perfectly ground points. Blue treatment is an additional thermal process which imparts a non-metallic surface to the drill, reduces friction, and absorbs lubricant, thus increasing drill life on ferrous metals. British and international standards lay down strict specifications for the dimensions of each drill. Dormer have now perfected a drill gauging machine which measures drills electronically at 3 positions: the point, the run out of the flutes, and the end of the shank. Each measurement is taken separately, and the machine remembers each one, correlates them for size and back taper, then determines whether the drill is correct or not. This machine is capable of working to an accuracy of 100,000th part of an inch and inspects 3,600 drills an hour. A tool made with such care demands as much care from those who use it. Make sure you've got the right type of drill for the job in hand. This information handbook will tell you. Make sure that the taper shank of the drill and the socket are clean and free from burrs. Otherwise, the drill will not fit correctly and the tang will twist off or the drill will drop out. Don't ruin the drill before you even start work by using steel hammers or spanners. A mallet of wood or some other soft material such as lead should be used. Make sure that the workpiece you're going to drill is rigidly held. If it bends or moves in any way, a strain is put on the drill which will reduce its efficiency and possibly break it. Reduce the quill extension to the minimum. Select the correct speed and feed for the size of drill and the material. Direct an adequate supply of coolant to the cutting area, not halfway up the drill. Make sure, too, that you're using the correct lubricant. Above all, look after the point of the drill. Don't let it get too blunt. You'll only have to grind more off to get it sharp again. And in any case, a blunt drill point produces poor workmanship. A blunt drill will speak for itself. A machine ground point is always more accurate and therefore more efficient than one ground by hand. It is essential that each cutting lip should be at the same angle to the axis of the drill, and that they should be of equal length. This means that there will be no difference in relative lip height. Each lip will then remove the same amount of material with a balanced cutting action. This Dormer drill sharpening machine automatically produces a perfectly balanced point. A chisel angle of 120 to 130 degrees will ensure efficient entry into the work and minimize peripheral wear. Too great an angle will result in drill wander and bell-mouthed holes. Too small an angle will make the chisel, and therefore the drill, ineffective. To allow the drill to feed into the work, there must be sufficient clearance behind the cutting lips. Too little clearance will result in the drill rubbing without cutting, and too great a clearance will weaken the cutting edge, with subsequent snipping and rapid breakdown. Correct clearance is provided on all Dormer drill sharpening machines. Each flank of the drill is ground from the same location point, therefore both flanks of the drill are identical. Correct clearance, point angles, chisel angle, and other features of drill point geometry can be checked accurately on the Dormer goniometer drill inspection unit. The core or web of a drill increases in thickness towards the shank to give the drill rigidity. Therefore, as the drill is shortened by repetitive sharpening, it becomes necessary to thin the web at the point. This operation is better performed mechanically, as it is essential that it is correctly formed and equally balanced about the drill axis. The economics of drilling, the actual cost per hole, depends entirely on the quality of twist drill and the care with which it is used and maintained. To meet the exacting demands of modern industry, many millions of dormer drills are in constant use throughout the world.